Hi everyone, welcome to another presentation. Here we have Vincent with us, and he's going to share what he did for his project for ROS Basics in 5 days. He's going to be working with the Turtlebot, and he's going to be showing us what he did with regards to moving the Turtlebot with the help of topic subscription and publishing, as well as using services and actions. So hi Vincent, how are you?
Hi, I'm good. Thank you.
Great. So, you have around 20 minutes, and the floor is yours. So, if you want to share your screen and present, and go ahead.
Okay. So let me share my screen.
Great.
You see my screen?
Yeah, let me just make sure over here we have it. Yes, we can see it.
I just connected to the real robot right now. So yeah, the goal of the project was to was in 3 parts. So first, read the scan topic to detect objects in front of the robot. And as a publisher, send messages to the command velocity topic to simply move the robot and make it move forward until it reaches an obstacle and stop. And actually, I only have the complete project. I don't have separate part 1, part 2, part 3. So I will explain the 3 parts and then I will just run it. So yeah, the second part of that project was to add a service that allows the robot to move in a square. So it was simply to command the robot and move for 15 centimeter, I made it turn left and do a square. And while stopping all the while, if there's an obstacle at any point in the path. And the third part of the project was to add an action on top of that allows to record the odometry along the way and just chain everything. So make the robot move in a square, then move forward until it reaches an obstacle and stop at any point if there's an obstacle and get the feedback from the odometry action and print out the amount of displacement that occurred during the whole movement. So yeah, let me try and run what I have now. I don't know if I should have moved the robot. I didn't really check where it was. No, it's not too bad, I think. So yeah, the odometry is not working right now on the robot, unfortunately. So it prints 0. But so right now the robot stopped
because it found an obstacle.
Yeah, it found an obstacle while moving in a square. So let me try and move. I think this should be enough, I think. Let's see. So the robot moves forward, turns left 90 degrees. Right now, the movement is not accurate because it's only time-based. So I just turn for the amount of time according to the speed, but for sure it's not accurate because it's not. It does not depend on the scan to do any slam kind of thing, or neither it depends on the odometry to know where it is. So right now the turn is not accurate. And now it should detect the wall and stop. So as you can see, when it stops, it gets the odometry output and 1 per second with the angles. I don't have the position, but at least you can see that the robot has turned and made a whole
Yeah, yeah.
turn.
And how did you get that turn value?
Yeah, so the turn was well, I registered to the odom topic,
Mm-hmm.
which returns a position and a quaternion. So I just got the quaternion and computed directly the angle. So I assumed that there was only one angle and the axis was vertical, and I
Mm-hmm.
just used the W part of the quaternion. Actually, I
Oh,
can.
okay. Nice.
I suppose there are easier way to do this, but this is what I did. I just did take the orientation quaternion, read the scalar part, and this is twice the cosine of well, it's cosine of half the angle. So I just did the inverse math and to get the angle directly.
Okay, nice. So, if you want, we can actually disconnect from the real robot and try in the simulation to see that, that
The
odometry
odometry.
part.
Yeah, for sure. I can do that. So let me do this. I changed a few things with respect to the original
Yeah,
project.
yeah.
I made a separate node for obstacle detection to avoid repeating the code actually to detect obstacle in three parts of the program, because the main, like the move in square service needed
Mm-hmm.
to know that.
Mm-hmm.
The move until obstacle needed to do that. And also record odometry, it was specified that it should stop automatically once it reached an obstacle. So there were three parts that needed to detect an obstacle. And I decided to make a node that published a topic called obstacle,
Oh,
which is
nice.
a Boolean. So uh, everybody listens to that node, and this is how at least everybody's synchronized. And I'm sure that if there's an obstacle, everybody agrees that there's an obstacle. There's not one that says there's an obstacle and the other one says there isn't. So
Oh, that's super interesting. So that's a topic then that you're publishing, creating, that you
yeah,
are going to have all of those nodes that you have there on the left subscribe to it.
yeah. So
Oh,
let's say move in
nice.
square, it
Ah, right,
subscribes
right,
to the
right.
obstacle. Yeah. So I had a little fun with that, and I made the algorithm slightly more robust in obstacle detection.
Mm-hmm.
Instead of just looking at the single point in front of it, I looked at 60 degrees in front of it
Oh,
and
perfect.
took
Yeah.
the closest point. So it's a little more less dangerous, let's say.
Right. Yeah. Instead of
So
just
yeah,
looking at one point. Yeah. Yeah.
exactly, yes. So let me start the simulation. And like this, I will start Gazebo. Okay, here we have our Turtlebot simulation.
Mm-hmm.
Let me tilt it a little. And yeah, so I will launch the program again. So each node actually logs with its name at the front so that it's a little clearer here, so you can see which node is doing what.
Oh,
So now you see that this is the feedback
from the
that
action.
you get from the odometry node, and you see that it's increasing slowly while the robot is moving. So this is the sum of the movement along the way.
Okay, nice. And once it completes the square, it goes straight until it finds the wall.
Yeah, yeah, should do that soon. Yeah. Yeah, I didn't make the robot move too fast either, because this is you don't want it to hit a wall or something.
Yeah.
I, I'm pretty new to, well, I've never used the ROS before, so it was really a first for me.
Oh,
So
great, great. Yeah,
yeah,
that's
it
good
was
to hear.
nice.
And I
and you have a
appreciate
real
the wanting to not go too fast. That's probably one of the reasons why the odometry is not working in the real robot right now, because people are just using it all day.
yeah,
Okay.
yeah. I suppose that this is the kind of setup that will uh, break hardware quite fast, having something that works 24 hours a day. So
Yeah, so we're constantly working on that. So okay, great. I see that your list spits out, uh,
yeah,
and
yeah.
that's
So this is like the main at the end gets the result message from the odometry action, and I just print it out. Yes.
great. Could we go a little bit into each of the nodes that you created? So I know you launched everything in at
Yeah,
once,
sure.
so we can probably like kind of figure out how you did each section.
Yeah, yeah. You want to look at the code?
Yeah, that'd be great. Just to get
Yeah,
an
for sure.
idea of how you did
I
it.
think I start with the obstacle detector because it's a node that every other node is kind of using. So I think this is the first one that we should look at.
Mm-hmm.
So that node subscribes to the scan topic for the LiDAR and publishes to the new obstacle topic, which is a simple Boolean topic. I
Mm-hmm.
didn't create my own message for that. Um, And what it does, it has three possible state. This is only like the initialization state, so that there's no initial message there that says there's an obstacle or not. This is only until the first reading. So either it says there's no obstacle or there's an obstacle.
Mm-hmm.
And that state, actually, I just made a Python property, so it's nice when the state changes, you get a log message, but you don't get the log message at each call, only when it changes. So
Oh, nice.
um, yeah, there are a few details. I think this was overkill, but I instead of having a single threshold of 20 centimeters for the obstacle in front of the robot, I added uh, what I call hysteresis. I am not sure how you pronounce this, but there's a different threshold to go between the two states so that you don't, at if you're at 20 centimeter almost exactly, you don't want it
Oh,
to shuffle between the two states in and out. So
oh. So you added that. So it. Oh, okay. I see what you did there.
yeah, there are two thresholds. So go from no obstacle to obstacle, you have to go below 20 centimeters, but
Mm-hmm.
to go from obstacle to no obstacle, you must go above 21. So
Okay.
the,
Okay.
it just a small buffer. So yeah, to detect the obstacle in itself, I take all the ranges, like the LiDAR measurements. The first one at index 0 being behind the robot and turning counterclockwise, if I remember correctly.
I think so. Yes.
Um, so I take the midpoint of that range, um, and I compute. At the top I said, okay, at 60, I have a watch angle of 60 degrees in front of me, and so I just compute how many LiDAR measurements 60 degrees out of 360 degrees it makes.
Mm-hmm.
And I read all those ranges, take the minimum, and I say this is the distance of the obstacle in front of me.
Oh, okay.
So yeah, it's simple, but it works relatively well.
Yeah, it's very clear and very useful because you can use this for anything pretty much after this.
Yeah. That's the goal also, because you want it to be, well, that's the strength I think of ROS, is having topics, and you can really divide your problem into small reusable components.
Absolutely.
Uh,
Yeah.
yeah. Yeah, so maybe we could look at I don't know, move and square maybe.
Yeah. Yeah. Well, let's look at that, and then your service. This is your service, no?
Yeah,
Yeah,
yeah.
yeah.
This is the
And then
move
the
in square
action, and
service.
then that's it.
Yeah.
Okay.
So the service is publishing to the velocity topic to move.
And
It's
subscribe to the obstacle.
subscribing to my obstacle topic to detect if there's an obstacle, creating a service. I did this so that I'm sure that I have read at least once the if there is an obstacle or not before starting anything. I think it's a nice thing to do to be sure that I've read at least once the topic, so I know there's an
Right.
obstacle right from the start or not.
Oh, okay. So that's the first thing you do is check if there's an obstacle in front. Okay, yeah.
Well, yeah, at least wait for the first reading. That's
Right,
what
right.
I'm sleeping until my callback got called at least once, because actually this is initialized to none, which is neither true nor false. So this will block until the callback has been called once. Maybe
Oh,
there's
okay.
a better way of doing this, but this is an easy way I did to be
So
sure that at least
yeah,
it was called
that's
once.
if it works, it works, you know.
Yeah, yeah, yeah. I'm sure there are more idiomatic ways of doing that kind of stuff, but yeah, this is my first time, so
I'm sure, but let me tell you that this is one of the most organized uh, codes, programs that I've seen. You code regularly, I assume.
yes, yes. I'm a software developer,
Oh,
so
then that's why.
the coding part is not the hard part for me. It's
Right.
yeah. I'm not a Python developer though, so I was googling Python commands along the way.
Like we all do.
Yes, exactly. But at least I didn't have to mess with make files. So
Yeah, yeah,
yeah,
that's the advantage.
yeah, yeah. So really, what the node amounts to is a move primitive that takes some twist command. So either move forward or turn or anything for a specific duration. And what it does is it loops until the duration has elapsed. So it just checks the time, but periodically it checks whether there was an obstacle, and if there was an obstacle, it throws an exception to stop whatever movement we were doing. And in the caller, sorry, yeah. So in the function that calls this, I just have move forward, turn left, move forward, turn left in a loop 4 times.
Okay, yeah.
But if there was an obstacle, I say, okay, it failed. This is for the response for the service. So I can say it failed. And finally, whatever, if it succeeded or not, be sure to stop it at the end. If there was an exception or whatever, be sure to stop it. So, and this is what gets returned in the end. So if you look at the moving square, it really, this is maybe again overprotection. I was not sure if it was possible to call a service while it was running, so I protected it myself. Maybe it was not necessary, but if it's already moving in a square, I don't want it to be called a second time while it's doing the first move.
Right. Yeah, that's a good idea. Although I'm pretty sure it would have to
Maybe,
you have to wait until you get the response from the service in order to try it again. But yeah, that's a good like fail safe.
yeah, yeah. I wasn't sure actually if it was necessary or not. So, but yeah, so it gets the request, which is empty. In that case, there's nothing in the request, and builds the response. Either it says false in my failsafe, that's probably not necessary, and otherwise it gets the either true or false whether there was an exception or not. For the move until obstacle, I don't think I will show it for time, but
Yeah,
it's really
it's the same principle. No, you're subscribed to the laser scan and you stop when.
yeah. Yeah, I made a separate node in the description of the task. It was supposed to be in the main node, but it was I found out it was so similar to the move in square that I made it into a service
Right.
also.
Oh, okay. Okay.
So that it's very symmetric when you look at the main at the main node, it just says create the main node, start recording the odometry, move in a square. If it worked, move until there's an obstacle, stop the recording, then print out all the odometry that you got.
Nice.
So yeah, the action at the end. So the action subscribes to the odometry naturally, also subscribes to the obstacle so that it can say that the action has terminated when there's an obstacle, and create an action server.
Mm-hmm.
So now there are two callbacks that can be called, the one for the obstacle that updates the obstacle, and the one for the odometry that actually takes the full 3D pose and reduce it to a 2D pose, let's say. So
Right.
XY
Yeah.
position. Well, this is XYZ, but I only write XY, and the yaw part angle.
Mm-hmm.
And this is for the feedback of the action. So the feedback, actually, I update it. I don't send it, but I update it inside of the callback. So it's very small granularity. I increase the current total by the distance between the current odometry that is saved and the new odometry.
Mm.
And then I update the odometry to the new odometry. So there's always the latest odometry in this member. And yeah, so in the end, the action is creating a result with an empty list of points and resets the feedback to 0. And until there's an obstacle or the service has been, the action has been preempted, it will append the latest odometry that has been read in the callback. This has been done this way because it was said that it should record the odometry once per second and not at the speed of the actual odometry. So that's why I saved it in a separate
Oh, I see.
member.
I see.
And I have a rate of once per second. Otherwise, there would have been a lot more points.
A ton of points, yeah. Because I
Yeah,
think the
and
hertz is, I think it's, I'm not sure about the odometry, but I think it might be 60 hertz.
I
So
haven't checked that, but yeah, it was quick. It was a little too quick. So this is what I done
uh-huh.
to solve that. So I published the feedback which is also increased in the callback, but published only once per second, which is the total travel time. And yeah, so at the end, it's just a print message and it says it was preempted or it succeeded, because it never fails. It can only be preempted. And yeah, I think I explained everything, I think.
Yeah, yeah. That, do you mind just for the sake of it, do you
Yeah,
mind
yeah,
running it one more time just to see
for sure.
sort of like the whole process in action again?
So maybe we could,
Or maybe do
well,
it so it will fail, you
oh,
know?
yeah,
So,
okay, yeah, I will do it now. It won't be able to turn
right,
left
exactly.
the whole way. Yeah,
And
okay, I will do it now.
it's going to be, you know, using your obstacle detector.
Mm-hmm. So yeah, there's no obstacle. It starts moving in a square. It will turn left, and now it should detect the obstacle. Yeah, you see.
Oh, and it
So
returns your odometries as well up until that point.
yeah, because this hasn't failed. Actually, it
Mm-hmm.
stops when the obstacle is detected, so it hasn't failed.
Right.
But the service returned that it failed. So if you look at the move in square service, it aborts, it stops, and the main gets in the response that the move in square has not completed, so it doesn't even try to move straight until there's an obstacle, it just stops.
Well, this is really great, Vincent. Good job, great job. It's very
Thanks.
clear. And do you mind stopping sharing your screen so we can see
For
each other?
sure. Let me. Yeah. Is it good? Yeah.
Yeah, let me
Okay.
just, okay, I can see you now. So, yeah, congratulations. It's so clear,
Thanks.
and it looks like you understood all the concepts really well. And I was actually going to let you know that there's another project that if you're interested, I can share it with you so you can play around with it, which is actually following the wall. So it's the same concept with the services and recording the odometry with the action, but it will look for the wall and then start following the wall around, and it's just a little complication that I think with the base of the code that you've written, it would be really simple to implement. So
Yeah, I
I
think
can,
it would not be too complicated. It's really the service that would have probably to be a little more intelligent and
yeah,
look at the scan. Yeah.
look at the scan on the right side and the left, and you just start going like that. But I mean, I just wanted to let you know that this is really impressive and really concise and clear on each step. And yeah,
Thanks.
we'll keep you updated on what we do. We're thinking about doing one that that detects a person, and you have to
Mm.
follow it, the person. So
With a camera or
with the
LiDAR
scan,
again?
with the lidar, I mean, you could
LiDAR again.
also. We're gonna add a camera as well to the Turtlebot, so you can do vision programs with it. But yeah, with the
Yeah.
scan, being able to identify 2 feet and be able to follow it,
Yeah, it
that's
would be
another
nice.
thing. Yeah, but
And I have to say, your setup is really, I was really impressed actually, like having all those tools available in a like web base without having to install anything. This is magic because you I know for that kind of stuff, you can spend so much time setting up your environment to reach the point where you can even start doing something. And having all that environment set up without any problem, I mean, it worked seamlessly, including connecting to the real robot and having also a real robot at distance in Barcelona. It's a really nice setup.
absolutely. I mean, thank you very much. And that is what we're trying to offer, because you're right. Sometimes you spend half or even more time trying to set things up, and that like hinders your ability to, what you're trying to do is learn ROS, not learn how to
Yeah,
set up your system. So thank you very much. We're going to keep working on it to keep improving it for everyone.
yeah.
And
I will propagate that knowledge to colleagues and
great, I
friends.
appreciate
Yeah,
it. Well
yeah, yeah.
then, Vincent, that's all for us. Congratulations again, and for everyone else that's watching. I mean, this could be you guys. So make sure you if you want to learn a lot and take a good solid ROS Basics course, take it and then present with us, and yeah, go from there, and you can start learning like here, like Vincent has done so proficiently, I would say. So
Thanks.
thank you again, Vincent, and I'll hope to talk to you soon.
Yeah, thank you. Okay,
Okay,
see you.
bye bye. Okay, I ended the stream, Vincent.